everybody. Thank you all for coming. My name is Ryan Brucks, and I'm Principal Tech Artist at Epic Games. And that means I get to kind of jump around on different projects, helping out on engine features and game teams and different things like that. I'm here today to give you an overview of some of the progress we've been making on the Open World initiative that Nick mentioned briefly during his keynote. We're going to go take a closer look at some of these features, including a few live editor demonstrations that should help give you guys an idea of what it's like to work with the tools, the type of content you might be able to create with them, and hopefully how they might affect your workflows and how you might want to start using them. But before we do that, we're going to kind of quickly go over what are some of the challenges of making a game engine great for open world development. And the open world topic is pretty diverse and expansive and probably touches most of Unreal Engine 4. So to kind of help simplify that, I think it helps to distill that down to a few major categories that we'll kind of go through and discuss the quick challenges that we face there and what we're probably going to end up doing to address those challenges. So for this discussion, those features are really high performance rendering, because you have to have, or high performance streaming, sorry, because you have to have a large world if you're going to have an open world, and you want to be able to stream that in just near your player where you need the most resources and the most detail. And you need editing tools that will work for any scale, because as the size of your world increases, the size of your edits might have to increase as well. And if you're doing large edits to, say, a gigantic mountain or river, in the same way that you're doing little hand edits like moving rocks and moving bushes around, it's going to be pretty time-consuming and costly to scale those edits up to your project. And then lastly, quality rendering at any level of detail. And that kind of has implications for streaming, just the quality of the materials in the scene and the lighting and a lot of other things. Okay? And it's also worth pointing out that Unreal Engine 4 already has a lot of tools and features that deal with these categories and does a pretty good job, but we always want to improve the engine whenever we find an opportunity to do so. This might help give an insight into what we're thinking of doing there. So some of the challenges for open world streaming, again, we have an open world, so presumably it's bigger than just a little courtyard or a slab of background mountains that games used to have before open world became pretty popular. So you need a way to separate those different areas into chunks, and you can think of that as having a grid or having different cells of the world. There's a lot of different ways to manage that. So obviously you don't need everything loaded at the same detail, and you want to know where your player is and manage loading that in. And that involves specifying and handling when and where to load those different separate chunks of your world in. And there's a lot of different ways to manage that we'll go into. But there's another kind of hidden side of this, which is keeping the content in chunks. Because after you've initially decided to split up some world into a bunch of little grid pieces or separate levels, it can be challenging to make sure that as you edit the world, it kind of stays that way and you're not crossing lines and breaking boundaries. So for editing tools, this is really about letting your users work comfortably at any scale, including really large scales. Because like I said before, you might have an open world project with big mountains or big rivers or continents or islands that you need to change the coastline or move this river over here. And doing all that stuff by hand on an individual level doesn't always scale and just takes too much time. And yeah, you can throw a lot of people at these problems and try to have them all work on different parts of the terrain, but then you have another issue of it's hard to have consistency and contention of files and things like that. And this really touches on a lot of areas that we'll talk about, mostly procedural tools and landscape tools. And that involves both hand editing and procedural, and leading to the next thing of lighting leads us kind of into the challenges of open world rendering. So one of the things we hear about a lot is that people really want to be able to do higher quality terrain rendering, and that includes higher quality terrain performance as well. So the big thing we'll be talking about for that today is virtual texturing, which there's some pretty exciting things you can do with it, and some interesting implications. And then another thing that comes up again and again, which kind of seems like an obvious, just really broad label, but it's accurate representation of worlds. So that means, even if you have the tools to create this big, gigantic world that you want, how do you make sure that it feels big and feels alive and feels plausible and all these things? So we'll be talking a little bit about atmospheric sky model that was mentioned during the keynote as well, giving a quick hint about that we're expanding that to a water model in the future, and how this kind of all works with different types of streaming and things like that. So jumping into streaming a little bit more, of course there's a lot of requirements about streaming. We have to handle the spatially separated areas. We have to let people support editing at different levels of granularity. So they have to have kind of let's say you need to do, like I said before, a small little edit to one area or a gigantic edit that touches, say, most of your world. You want to have kind of a sane option that makes sense for both of those cases, and then everything in between. And then this all has to be linked to the level of detail of your objects and things. And of course, touches on HLOD, which I remember there was a question which I'll try to slip in a little bit of an answer into one of the upcoming slides about one way that you could address that. So the status quo for managing this streaming in UE4 has been world composition, and there's nothing new there, of course, right now. That's been in UE4 since roughly the early days when we took UE4 to the launcher and that sort of thing. And it includes a lot of nice features out of the box that can get you started to a pretty good place. You can lay out your levels in a streaming grid with a 2D viewport, showing all the terrain. You can import tiled landscape chunks, which is a pretty common workflow that we see. People use external programs like Houdini or World Machine or pretty much whatever, Vue, to bring in a bunch of different chunks for their landscape. And then that forms a nice starting point of a pre-split grid that you can then use as kind of your world granularity. And then it gives you the option to create whole level LODs. And of course, Unreal Engine 4 has the proxy LOD generation now to replace Simplygon. So you can create those whole LODs without any separate licenses or tool requirements. And usually this is managed by people by going with either scripted or volume-based solutions. Probably volume is the most common, where you'll just have level bounds for each object or level in the world composition, and then it'll kind of try to automatically stream those in based on the level bounds. And you can, of course, override and customize this, and a lot of people go with custom solutions as well. So there's some challenges to using world composition, even though it does give a good foundation to start with, like I mentioned. We mentioned before keeping content in chunks. So that might sound kind of like a silly quick thing, but there's actually some implications worth considering. So let's imagine ourselves as either level designers or level artists or environment artists assigned to pretty up this little patch of our open world, a little tiny level called level A. So we think, okay, there's some trees, but they look a little lonely. We need to add some more happy trees. And so we're going through populating our level. It's starting to look pretty good, up until happy tree turns into sad tree because someone accidentally placed it outside of the bounds of the streaming area that they were actually working on, which might not be obvious at the time that they're performing the edit because it still looks like it's on the terrain. It's just that it's not in the right level. And the side effects that this can cause it really depends on which streaming solution you use. On the one hand, if you're using level bounds and they're automatically calculated, this little tree over here could suddenly just dramatically increase the size of level bounds and really throw off some of the performance and profiling data you might be getting on your project because you really need to have consistent, repeatable test results when you're optimizing for a performance target. And if you have daily testing where one day the build was broke because the bounds got all huge and the data looked like it was really expensive, it makes it hard to gauge the effectiveness of your other content changes. And then in the other case where you're specifying the bounds manually, it can cause an equally bad problem in the opposite direction where those trees just vanish because you weren't close enough to the level where they were placed in, but should have been placed somewhere else, which that can also cause falsely high positive performance reports as well, because hey, what if half of this level was placed over here and it's not even visible in this performance test? So the solution, of course, has been to manually maintain and fix that up. You figure out which area does that belong in and where does it go. So we've identified this as something we really want to improve upon because even internally we spend a lot of time on these things. So one of the solutions, and this was also mentioned in the keynote, is that we're exploring a upcoming mode to manage sublevels based on a grid automatically. This is just an image from a prototype right here, but hopefully it conveys the rough idea that we have a concept of a grid splitting up this terrain or floor surface here. And as we drag objects into the world from, say, the content browser or the little asset palette there, it automatically is figuring out where that object needs to go. And then that also takes effect as you're dragging the object around after it's been placed. So obviously this is just debug text and debug prototype stuff showing, and that would be something you would optionally turn on or off. But the point really being that you wouldn't really have to worry about that anymore. It would just be handled under the hood automatically by the engine. So of course there's still some challenges when having levels in grids based on the different paradigms in the engine. One of the challenges with world composition is that you can't really nest multiple levels within other levels. So that leads you to kind of have to face some different choices. So let's say here that we have a little house, and it might be ideal to say, hey, this house should be its own separate level so that we can modify this house level without having to check out the whole terrain chunk or whatever that happens to be there. And of course, some of this is addressable by having multiple different streaming grids in your world, but some of that gets pretty advanced and complicated to set up. So we're looking at ways to kind of ease some of the tension. So what this kind of image is trying to show here is that in the one case we have a house level by itself, and then the one that's blue being placed on the tile there has kind of been placed as actors directly in that landscape tile, which people also do pretty often to avoid having tons and tons of different persistent levels streaming. So yeah, the two choices people often make to work around this is either they'll still have their individual house levels, but they'll have them all as persistent levels in the same top hierarchy so that world composition can reference them, or they'll just manually place them in the content browser, or sorry, the level browser in the editor. And both of those kind of come with side effects. Either you have to then check out the persistent level anytime you want to move a house or adjust something, or you place them in the grid maps, like I said before, and suddenly you have the problem of file contention. In this case, we have an example where that same patch of terrain, which has the trees and the terrain in the house now, because in this example, we decided to put the house into the terrain. What happens when we have 4 or 5 people trying to work on some objects in this area? Whoever got it first ends up winning. And there's also a bunch of other cases, like someone well-intentioned was about to check in a really awesome fix, but then they had to run home right at 5 o'clock because something happened at home, and then someone else was meaning to use that same content right after them. So then you have to involve IT, and they'll have to revert the person's checkout and make sure, hey, I hope you didn't lose too much work, otherwise you're going to have to redo it. So trying to solve that kind of gets us back to another point from the keynote, which is file per actor. So right now we have the whole concept in Unreal of a level, which is one monolithic file containing a bunch of individual assets like actors and objects and volumes and all sorts of different things. But that means if you want to touch something in that level, you always have to touch that file. The idea of separating actors into different files is that now, instead of having to just touch that level, you'd have all those different files where each can be each can be modified. Like a tree or a rock would have its own transform information in that file, so you could just check that out and move where it is within the level without having to worry about that. And then that means you could still have attachments and things like that. So in theory, it would make it better and easier to have a nested hierarchy of different actors. So now jumping and changing gears a little bit to editing tools, talking about landscape. And landscape is obviously pretty important and at the core of many open world projects. Because you usually want some sort of foundation of earth for your game unless it's purely an urban environment, for example. And one of the important things about landscape goes back to one of the early requirements that as the project scale increases, the tools must also scale with the project. And that can refer to a couple of different things. Right now, we're going to be talking about kind of 2 alternatives, which is either making handcrafted edits more powerful. So going back again, moving mountains and sculpting gigantic canyons and things like that in the same way and with the same ease and speed that you might sculpt a pothole or make a tiny adjustment to a sidewalk. And then the other side is procedurally created content. And that can be, at the base level, it's something as simple as procedural noise to be the base of a terrain before you start in really sculpting it out by hand. Or it can refer to procedurally scattering objects with procedural foliage, or even using blueprints to do spawn actor with some custom logic, which there's a lot you can do right now, but we have some improvements that we're excited to show as well. So the big thing for the landscape improvements right now is the new layer system. 423 included this as an experimental feature. It's called the layer system. And it's also worth mentioning that in 24 is aiming to have this system go out of experimental and into beta. So the layer system allows for a full stack of compositing layers on your terrain. And it's kind of up to you how you want to use them, but there's just an example of you might want to have different features of different types of editing on different layers. So what you can think of these like is each layer is another complete terrain data set, meaning we have access to paint on a new height map and a copy of each new paintable layer where we can make kind of custom edits. And these are all non-destructive in that they don't affect what is below them in the stack. You can easily hide and isolate them. And another question that was asked before was blending. You'll notice that on the right, that's an image of the landscape mode with the layer system. And next to layer 1 is an opacity or an alpha on the very right. So yeah, you can click the eyeball to easily hide and debug these things to see, hey, what's going on? Why is this layer making this weird spike here or something? Or you can just type opacity to 0 or 0.5 or whatever you want. And that's pretty useful. And it's also worth pointing out here that the layers currently, they always have a fixed blend mode of being kind of a relative add to the layer below them in the stack. Meaning when you add a new layer, it shouldn't actually change the terrain right away, but you then have the ability to paint down or paint up or use flatten or noise or different brushes like that. And they should be expected to work as normal, although keeping in mind the experimental/beta nature as well. So this is pretty flexible and up to you how to use, but as an example of one way to use it, let's say that we have a few different layers. We have our block out layer, where you might want to mass out kind of the basic foundation of the terrain for your area. You could think of it as what is the natural geology of this area of the world that's not likely to change in the course of our game, that's not affected by man-made objects and that sort of thing. And then a spline layer, which could represent things like roads or rivers or paths, trails. And then a building foundation layer could be thought of as almost a scratch layer for quick edits that help tie human-made structures into the landscape. Buildings might need to have a little flat area where they nest into a slope, for example, or roads or towns might have a nice little clearing area that you want to be able to tweak. And that comes with some interesting benefits. So just a quick little animated image showing how this works. Here we have the blockout layer being shown as kind of an island shape with some noise. The spline layer being a landscape spline, and then a foundation layer just kind of making some tiny little adjustments on top of that. And notice we can look at just the foundation layer and see some little modifications that it did. So one of the things layers can help with is to avoid redoing work in cases where you need to change your mind or move something around or undo something. And this is an example where, say someone created a nice procedural noise basis for the terrain and then later went in and flattened out some spots for buildings or for maybe a soccer field or a stadium or something like that. And then later you decided, hey, that shouldn't be there, we need to delete it or move it around. If you had done that layer that edit in a layer, you could actually just use the erase brush and go ahead and erase that little foundation splat and go back to where you originally were. So when we say it's non-destructive, that's really what we're talking about, in that it's non-destructive to the data within the other layers. So it's also worth pointing out that the serializing saving process of the layer system bakes everything down to single layers. And that means that there's editor-only cost. So in the editor mode, you'll have some extra render targets and extra textures in memory for a time. But the cooking process simplifies that all down. So even if you have 4 or 10 or 100 layers, it's going to export it down to a single texture for each layer and weight map as well, in addition to whatever other packing the engine does for different platforms, such as we pack weight maps into the different channels of a texture, for example, just to reduce samplers. So of course, some of the experimental risks, which will be going away a little bit when this goes to beta in 4.24, but of course, still in development, features may change, editor optimizations are still being implemented, and I'd also like to say that some of the caveats that were mentioned in the keynote also apply here to this talk, in that this is not all-inclusive. There's a lot of other open-world features as well going on, and et cetera. So I mentioned spline systems. We also have an improved spline system now that works with the layer system. And the big change here is that the splines can non-destructively carve the terrain. And that means that as you move them around, they will, as soon as you let go of the mouse, carve out the terrain with whatever settings they have. And so here I'm just moving around a couple points, but also adjusting some settings like the fall off and blending of the edges. So you can change things like the width of the blend at each point. And there's also some texture-based effects that this image doesn't show because I didn't have time to get an example of that, but you can basically break up the texture. If you want to have asphalt or gravel, you can kind of use noise mask to modulate that a little bit and make it look more interesting. So the next thing we'll be talking about is landscape blueprint custom brushes. So this is a system that was exposed through the layer system again. And what it does is it gives control of the landscape to blueprints, or rather control to modify, and of course break the landscape if the custom brush is broken. But so you have to make sure you hook them up correctly. The idea behind these is that it gives you power to use the GPU to modify the landscape. So this is in 4.23 by the layer landscape system. Although there's not any example content or introduction to how to actually use this, 4.24 will have a plugin that will, and an example project which will help it be easier to figure out and see how it works. Going back. So the basic process here is it starts from landscape, which calls a render function for a blueprint. And then that blueprint dispatches render material draw events to the GPU, which then come back as just a series of textures, which then get reprocessed and sent back to the landscape for the compositing process of the layers. So the blueprint brushes work with the layer system. So whenever you add a brush, it goes to one layer or another. Unlike splines, they don't require the layer to be reserved for that purpose. You can actually add them to a layer and then still hand paint in that layer. Although right now, I believe that the brush is kind of in the higher priority of the two. So if you want to do something like have a brush that does stuff and then edit with hand brushes or hand sculpting on top of that, you would have another layer above and then do the hand edits in that above layer. And these brushes can affect either height maps or paint layers. And that means also multiple layers. You're not restricted to just choosing one. So what this looks like at the most simple form in blueprints is using the render function. You just drag a custom brush into the world in landscape mode, and it'll assign it to a layer automatically. And then whenever that brush is modified or the landscape is modified in a way that requires this to update, it'll call render. It'll pass in a reference to the render target that is kind of like, what is the value of the terrain before we apply this brush? And then in the blueprint, you basically take that and pass it to a material, access that in a material and do some changes, and pass the result back on the return of the render node. And that return render target is basically whatever will end up on landscape. So the best way to get an example of this is with 424 with the experimental plugin landmass. So we'll be talking a little bit about some of the custom brushes that come with landmass right now. And you can also get access to that on GitHub if you guys are set up for GitHub access for really early adopters, which I encourage. So what this looks like inside the material space is basically you're reading the height map, height RT texture there, which is a texture parameter. So you can assign it using a blueprint to read the value of that texture that came in, and then doing some modification to it, which in this case we have some displacement texture, that little noisy Voronoi looking thing that we want to add to it. And then the thing to point out is that landscape stores values in a quantized format internally. What they represent is 16-bit integers, which means you have a value from 0 to 65K, but it stores that using an 8-bit texture format with 2 channels, RG8. So there are some functions with landmass to unpack and repack that data before you return it, which you'll need to do. Right now with just 423, you'd actually kind of have to figure that out yourself or look at the code for how the landscape does that packing. So I'd recommend looking at landmass and getting these 2 functions to get started as well. And basically the workflow there is you sample as normal, you place the unpack function just on that render target of the landscape. Then you can do regular shader work because you have regular values at that point. And then just before you return the output, you repack back to RG8. So here's an example of a custom brush that just does noise on top of the terrain, which is a pretty fun place to start. You can see by having different amounts of octaves and persistence, you can have different levels of terrain where it's kind of starting to get smooth with little bits of noise versus just very jagged very quickly. So you can try out some different looks and just use that as a way to start out at the foundation of a terrain. And you can also do more advanced effects, such as generating distance fields and using those distance fields to carve out and affect the terrain in pretty custom ways, really taking advantage of what the material editor can do. So the process to create these distance field-based brushes is still all using blueprints. And there's kind of a process involved starting with spline data. So all these shapes for these brushes that we're going to show start with splines that are just drawn out like regular splines, but they're kind of always assumed to be a closed loop spline. You just don't have to connect the last 2 points. So you can actually render this out to a canvas mask using blueprints by using draw material to render target, but instead using a slightly modified version with a just draw canvas where you give it a list of triangles. And notice here that it's not actually rendering a triangulated mesh with proper triangulation. It's just using a winding order trick where for every polygon, you draw one of the verts back to the first vert, and then you flip the sign of the material based on the winding order, which in UE4 is just the node 2-sided sign in materials. So that causes it to kind of cut out the little chunks where the spline went the other direction, and then you can get a result, which is just a little mask texture. And then that mask starts as the input to the next phase, which is generating the distance field. So that works with an algorithm called jump flooding, which maybe some of you are familiar with, but basically the idea being that you first run an edge detection step where you specify certain seeds, and then the jump flooding algorithm spreads those seeds out and always finds the nearest seed for any point and returns what's called a Voronoi diagram. And that basically tells us it's a diagram of where the closest point to any other point is. And then from that, it's pretty simple to extract a signed distance field. And the sign inside a distance field basically means it contains information about both the inside and outside of the shape. So notice here for that little jagged mountain outline that we have bright values inside the shape where it peaks, which continue outside the shape for the whole range of the texture. In that case, it's biased so that the boundary is actually at 0.5, and then anything 0.5 and above is positive, and anything 0.5 and below is negative, or flipped depending on your interpretation of is the inside positive or negative. So one of the useful things about this distance field is because it's a continuous field that covers the entire region of the texture here, which also happens to be the entire landscape. That means you have a continuous intersection that continues beyond the point where the brush contacts the terrain. And that means you can start to use operators like smooth min and smooth max for advanced blending where those brushes intersect the terrain. And you can separate that by inner and outer edge as well, which is pretty interesting. And then you can kind of take that a little bit further. I know going back to the previous question, the previous keynote about the blend modes, while the layers themselves do not have different blend modes, you can pretty easily implement your own blend mode in a material for a custom brush. And it kind of does that. The way that this works under the hood is you can give it any result, and when you pass it back to the landscape, it kind of makes it relative to what was underneath it at that point. So that means you're pretty free. You're just returning an absolute value of the landscape at the end of this. So you can do, for example, here, alpha blend, min, or max, or just an additive brush. And you can see these all have pretty different effects on how it deforms the terrain. And in addition, there's the option to cap the shape or not. And that goes back to the signed part of the signed distance field. The capped shape basically says we just write a 0 or a 0.5 for the whole middle of the shape. We don't let the field continue in. And that just kind of automatically caps it, which is interesting. So I mentioned you can do more texture-based effects with the materials, and you can pretty much do whatever you could imagine in the material editor and make it as expensive as you want. So here's an example where we start with the raw shape, which you can see is triangulated in pretty low poly, and then we add some curl noise, which starting with some large distortion and then some smaller distortion gives it some more natural earth-like features almost. And then the distance field blending is the lower left there, the edge smoothing, which gives it a nice smooth transition down into the terrain. And then displacement is basically just adding a texture displacement result like that example material slide. And then terracing is an example of just creating some terraces with the brush as well, are all things that you can do. And these are effects that are included with the landmass brush as well. So the other cool thing about having brushes like this inside the layer stack is that you now have a list of brushes in the landscape tool, and you can just select and drag and drop them around to reorder the priority. And that means if you have, this is an example of 2 brushes. Well, actually it's 3 brushes. We have one material-only brush doing the noise. We have one brush for the canyon, and then one brush for the mountain. The only difference between the canyon and mountain brush is the cap option, the cap shape. And then changing the priority, you can see either the mountain's on top or the canyon's on top. But it makes it pretty fun and interesting to try different combinations, just messing around with gigantic shapes. So some of the experimental risks with the landmass and custom brush system right now is that performance is not quite where we want yet. That's in large part due to the fact that each brush currently just renders the entire landscape and returns the whole landscape result. We have some early tests of optimizing that down to just affected regions, but they're still a little bit too error prone to make the default behavior. And then another issue is that we've learned from actually using these tools in-house on some of our game projects is a map dirtiness issue, which currently could cause you to get prompted to check out levels which you didn't actually modify, just due to really subtle precision changes in a few pixels. Most of the time it's ignorable and we can deal with it, but we hope to get that fixed soon as well. I'm gonna go actually and jump ahead into the editor real quick and demo some of that stuff. So here we have just kind of a pretty blank level that has a landscape, and it's been set to use the new layer system, which we can find when we click on the landscape and just go down to its details panel. It has enable layer system checked, which is just a box when you make a new landscape as well. So I'll just go ahead. So if we do new landscape, we can see we have enable layer support there, which already went ahead and created one here. So what does this look like? You can see we have our landscape. Most things behave as normal. We still have our manage, sculpt, and paint. But we also have this new little layers area, which shows our layer 1, and what are the targets of the layer, and that includes, so we go to paint mode, and we have all these targets we can paint in our rocks, and our scree, and our grass, and whatever the material has set up. So we could go down here and create a new layer, and now we have 2 layers, so I could kind of do a really quick version of creating that little example from before, where say, on one level we have, And this is what I'm talking about when I talk about scaling edits, is this isn't usually the type of edit you want to do with a hand brush if you're making a continent. But just for the sake of demonstration here, let's say we have we have two different brushes here now. We have one brush affecting our continent, and then one brush affecting some little edits that we did afterwards. And notice, we can come down here and set that to 0.1, slowly fade it in, pretty much whatever you want. You can also reorder them, which in this case isn't really doing much because they're just additive, but it will affect in some cases depending on opacity and things. I'm going to go ahead and delete one of the layers again. Oh yeah, also to show that when you go over to paint and you have these two layers, I mentioned before, but you actually have kind of a unique copy of each of these layers to paint in. So I could come down here and just paint in rocks, and that's just in this layer. So if I hide that layer, now it's gone. And likewise, I can just paint in this layer. And then you can go in and erase them as well. And there's also subtractive blend mode, which can be interesting if you want to have a layer that's higher up, dedicated to just erasing some things that were lower down. That's also an option. All right, I'm going to go ahead and simplify this down a little bit and talk about the Blueprint custom brushes. Let me clear some of these effects that we did real quick. So there's also some different options for clearing now. When you right-click a layer, you can clear all sculpt layers or all paint layers as well as sculpt layers as well, which is useful for when you're just duplicating things around and you're not sure how you want to use them. But the next thing to show is the Blueprint custom brush. So we have this new mode here in both Sculpt and Paint, Blueprint custom brushes, and we also have this little custom brush layer stack down here. So how that works is with the landmass plugin, which I've enabled here, which you've got to do show engine plugin and show plugin content. Then that'll show up down kind of under engine. Under landmass blueprint brushes, there's some simple blueprint examples in here. We're going to use one that's a little bit more fully featured to show what can be done. This is the custom brush underscore landmass, and you can also make children of it that have custom overrides. So I'm going to go ahead and drag in this landmass brush canyon, and notice it added it here to the layer brush stack. It doesn't look like it did anything just because it's coincidentally sitting at the right z-plane, I hope, as it works. So we can see dragging it down, it's affecting the landscape, and it's kind of using the shape of the spline. We could come in here and start editing it or alt dragging to modify it. The way to know when you're alt drag which part of the spline the new point's going to go to is if there's a highlighted orange line, the alt dragged point is going to go to that side. Unless you're at the very end spline, and it's going to make a new point. So that's kind of just how you define the shape of the spline. And then getting into how you modify it, that's still done through the details panel of the actual brush actor. So right now we have this kind of settings list, which is under brush settings. The type is basically you can change to also use things like spline meshes or single static meshes or material only to bypass all the functionality of the distance field generation. There's different alpha blend. So min wouldn't change anything here because we're only lowering. Max, want to edit the actual brush. Max is only raising up. And additive won't look like it's changing anything here because there's nothing to see from the base layer, but it's effectively just additive. And then the main things that you might want to change under here are the fall off. The rest is pretty much overrides for when you have the material or the mesh or the spline, as well as how you communicate to paint layers. So I'm going to go ahead and show fall off, which is currently set to angle. That's why when I lower this down, the size grows as it needs to maintain that current angle, which I can kind of lower that down to almost flat or make it really sharp, which you don't really want to do 90-degree cliffs in landscape. You want to give the system something to work with. And then, of course, you can offset these shapes to shrink or expand them. Or you don't have to use angle. You can also use width-based, which width-based is different because now it's not expanding or contracting based on the intersection of the object. So I'm just really quickly going to make this look a little bit more interesting since I'm using more time than I used in my rehearsals, apparently, which is okay. But so we've set this brush up. It's kind of acts like a vague start of a canyon. I'm going to go down under effects to see some of those material effects that we talked about earlier. So the interesting one here is curl noise. And right now there are 2 octaves of curl noise exposed. So we have kind of a large octave. And we can kind of slowly turn this thing up from 0, kind of creeping in, and it applies this distortion to the beginning of the distance field generation stage, so it kind of creates these almost eroded looking slopes, and then adding in some more detailed values, for example. So you can add a little bit more detail, tweak how you want this thing to blend. I'm going to go ahead and set it back to angle, so I think angle works a little bit better. Go for a shallower angle. There we go. So now we've got kind of a nice little start for a canyon. And then we can select it and go down to other things, like we could add a bunch of texture displacement if we wanted to. We could do the smooth blending operations I mentioned before, such as if we wanted to softly blend on the inside, or maybe a little bit more of a crisp blend on the outside, but still there. So that's basically a quick overview of the height stamping ability of this. And of course, these are just regular actors, and as long as you are inside of the landscape tool, you can duplicate them and scale them and do whatever, just like you could with regular actors. So I just pressed Control-C, Control-V to duplicate this object. And now notice I'm just kind of moving it around like I would any other object and able to change how it affects the landscape. And I can then come and modify some of the blend modes. Like maybe we don't want to cap the shape on this one. Maybe we want this one to be more of a mountaintop. So we're going to kind of place it and move it around. And this will help demonstrate one of the things about alpha blending is that it's kind of a combination min and max mode, and that you'll see it's kind of lowering the terrain up until it meets the intersection point, and it's raising the terrain up until the intersection point. So it's not truly like an alpha blend mode when it's set to angle, but when it's set to width mode, then it really does behave. Like a traditional alpha blend. So going back to angle mode, and uncapping the shape. We can go over here to our layer stack and reorder this. So if we put the canyon below, or the mountain below the canyon, now it's kind of like the canyon is going to cut out the mountain wherever we put this thing, which we may want or we may not want. And notice it'll cut out as high as it needs to go to maintain that angle, which sometimes you want to use width mode to avoid that. So for weight maps, I'm going to go down here real quick. Only got 7 minutes. We have some regular paint layers down on the landscape, such as rocks and scree. So all we really have to do is select our brush and add a paint layer to this paint layers array. I'm going to say rocks. Oop. And it showed up and then it went away. Hang on. There we go. So this is using the same distance field blending, so you have control to change the width of this blend. You can set it to be pretty soft and big blend if you want. You can set it to use texture breakup to break up the influence, and that's all controllable by the distance field gradient as well. So what you're really doing is kind of modulating that intersection. But say we don't probably want that much texturing on this point. What we really want to do is put rocks on the cliffs. We can go ahead and flip the sign of this width, and now it's going to go up on top. And we can also restrict it to not go on the continue going. We say, what if we want to give a limited range? We can kind of find what's the value that we need, and then kind of type that in. And these are also not limited to single layer effects. We can go ahead and add another one down here. We had scree, if you remember, so I'm going to go ahead and add scree, but of course it did the same thing. I put it at the very bottom. We might want to use edge offsetting, and we might need to move it up a little bit more. So I think what's happening here is our rock is actually covering up the scree when we shouldn't be doing that. So we could actually solve that by shifting the rock up the hill a little bit. And now let's say we want to take the scree, and we're going to flip it as well. But then we might need to flip what our bias is. And then we can apply a little bit of texture to that with the same breakup effect. We might need to give this gradient a little bit more width to play with, because you can kind of only modulate within the width of the gradient that you set. And you can also play with shifting around the effect by changing the midpoint of that displacement texture, which can be pretty interesting. So we've kind of shifted it a little bit too far. There we go. And then maybe we need to adjust our rock shift a little bit as well so that we're not covering up all of it. And we tighten that up and then move it down. So then we kind of have nice little scree piles just at the bottom of each of these mountains by playing with some of these distance field settings there. All right, I'm going to jump over to some other things again real quick, and then we'll jump back to the editor here if we have time. So next, talking about procedural foliage improvements. We've had procedural foliage tools in the engine for a while, and they've been able to read landscape in some sense. They can previously do what's called inclusive layers. So say you had a grass layer that you wanted to always spawn these tree stumps on or these moss pieces, but you also had this rock pebble layer where you wanted to not do this on. Right now, what you would kind of have to do is also erase out the grass where this rock is to avoid that. And we added exclusion layers, which means you can add list of layers to not spawn foliage on. And what that really does is makes a computed just-in-time mask for that foliage so you can have more control over how it's spawned. And this is on foliage type actor, which showed there at the bottom left how to create that from the content browser under right-click foliage. And then this is also making an actor foliage as well. So foliage tool can also print blueprints and actors, or place blueprints and actors as well, just like regular foliage, which has a lot of advantages for basically scripting and doing gameplay in open worlds, because you can place down a lot of trees, and those trees can now have coconuts or scripted beehives or a bunch of gameplay and effects attached, and it's a nice, more flexible way to do that. So next thing I want to talk about is with rendering is virtual texturing. So there's two main virtual texturing systems in UE4. There's the streaming VT and the runtime VT. We're mostly going to talk about the runtime VT right now, but just to help with a quick rundown of the difference, the main difference is that the streaming VT is streamed from disk, and its main idea is to save memory, but it costs some performance. The runtime VT is generated by the GPU on demand, and in general, it costs memory, but it can save some performance. And that's where we get a lot of interesting blending effects and different features we can do inside of materials is from the runtime VT. And with the streaming VT, you're really still dealing with individual textures and materials. In fact, nothing should really change much from a user perspective other than you check the VT checkbox on the textures, and in materials, you have virtual texture sampler types. For runtime VT, it's a little bit more complicated because you have separate textures and materials all contributing to one combined virtual texture. And then that virtual texture is updated on demand. So that makes it more well-suited for complicated blends where you have lots of decals and objects and terrain layers all making one really expensive mega shader, because you're not always rendering it unless you need to. So for streaming VT, the idea is that if you have a really large texture that's high resolution across a large area, you probably don't need to have that in the same resolution everywhere. So that allows kind of breaking up textures into grids and only streaming it in high detail where you actually need it close to the camera. And shown there on the left is a grid with a color for which level of detail the texture is using. And you can see it kind of cascades back. With runtime VT, you can do things like have objects combine into one single texture, and then the VT can be sampled by other materials, even those that are contributing to the VT themselves. So you can have roads that are writing to the VT and then displaying the VT so that you don't have another shader to deal with, but you still get the mesh ability to cause silhouette and make sure collision matches and everything like that. And as before, it's ideal for expensive multi-layered materials. You can do really cool things with virtual texturing, such as automatically blend static meshes into the terrain seamlessly, which if you've ever tried to use photogrammetry assets or rock piles with skirts, it can be kind of frustrating because you start placing these things and it covers up the look of your terrain and it starts to look really obvious from a bird's eye view. So these sort of things really help you get the most out of these assets and make sure they always feel like they're making sense and that they're being used properly, even if you really are just scattering the same mesh. So what this looks like on the content side is there's two different nodes that are important. The first one is runtime virtual texture output, which has to go inside of a material that is rendering into the VT, and it kind of just defines what you want to go there. And usually you just use material attributes or your layers and you pipe some stuff in. And then for sampling the runtime virtual texture, it's pretty much the same thing. There's a sample node, you place it in the material, and then you sample it like you would a standard layered material attributes layer. And for the height blend that was previously shown, that was done using an intersection blend using the runtime virtual texture world height. And you can see we have a world height value on the sample node down there, although that uses an actual separate virtual texture in the map. And that's done here. What we do is we take the world position of the object that we're rendering, like the rock, and we subtract from that the world position of the virtual texture, and then biasing and dividing, and that gives us a nice gradient that starts at the point of intersection, and we can blend it to be whatever, modulate it with textures like we were previously showing a little bit. So here's an example of a scene based on what we were looking at before with some little scree rock piles and cliffs that are all blending together with virtual texturing on both the terrain and the landscape. So another thing to talk about is the new sky atmosphere. This new model is an accurate multi-bounce Rayleigh scattering model, and it's a great way to bring realism and scale to scenes. So some of the most exciting things about this new system are first that it scales from really high-end PC to mobile, and we're also starting to use this in Fortnite pretty soon. And it supports a lot of advanced features such as planetary views, meaning you can see those tiny planets there are literally made by making your planet radius small in the fog settings or the sky settings, and then flying the camera way back. You can do dual sun and moon for space games and sci-fi. And most importantly, for content creators, a lot of the parameters and rendering features for the sky are set up with parameters exposed for artistic tweaking. So when you use a sky atmosphere in your scene and you place in a skylight and you set it to capture from the scene, you actually now get proper sun-sky luminance and color, which is great because it allows you to tweak the scene and get instant feedback, especially once you set your blueprint. You create a blueprint that forces the skylight to dynamically recapture as you're editing things. That can be a really important way to see a full dynamic response from your scene. And this also does tie to height fog, which another question from the last talk. Currently, if you have just a regular height fog, what you want to do is turn off all the directional and ambient scattering options, and the sky will start to drive the scattering values, and it'll just match the horizon of the atmosphere sky automatically. You can use it with volumetric fog, but the volumetric system is not fully linked with the colors and things like that, so you'll break some of the color for the skylight because it'll be rendered as unshadowed into the skylight at the moment. But if you turn it on and keep it at kind of like a small value, it can work without too many problems, but that'll hopefully be updated soon. So one of the really cool things about the atmosphere sky stuff is that there's a bunch of new material nodes that were added to help aid in the creation of custom sky dome materials. So we see here, these are basically the different main components that are used inside the actual rendering of the sky, such as what is the luminance from the sun at some point in the sky, or what is the luminance from the distant scattering, which is all the blue Rayleigh bounce that's coming to a certain point, the sun disk, and aerial perspective. You don't have to use all of those. You can just use a couple and make a quick attempt at color matching the sky, for example, which this slide is an example of that here. This is actually just the default Unreal Engine default sky dome texture that was updated to use these colors and kind of a fake lighting effect based off just shifting the texture around based on the light vector. But you can get a pretty convincing and well-matched result without a lot of work. This was just a kind of a quick prototype to test that it's working. And then you're also not limited to using that node on simple, just texture-based skies. So unlike the last one, which was just a regular sky dome texture, this is applying those same values to a ray-marched atmosphere, represented kind of using a custom ray march effect, which was an old prototype. It's really slow, and it's not been corrected or tweaked for physical accuracy or anything close to that. But it's still pretty satisfying to see that you can just take some custom ray march shader, plug in these nice lighting values, and suddenly you've got something that works pretty well. And it seems like I might have time to do a quick live demo of that, which is great. I'm gonna go ahead and leave that slide up real quick. Go ahead and load a different map here. Okay, so I mentioned before a blueprint to recapture the sky. We have one of those in here, which is just a simple blueprint that has a reference to a skylight, and really on the event graph, it's calling this recapture sky function, which allows us to do things like we can maximize the screen, go into G mode, and then another really cool feature that was added by Sebastian Hilaire, who worked on a lot of this sky atmosphere stuff, is you can now hold Control L in the editor, and you have a nice little gizmo there where you can rotate the sun around. So how it works is that left and right movement is the horizontal rotation around the z-axis, and then up and down movement is kind of like how high it is in the sky. So it makes it pretty easy whenever you're in a certain view. You don't have to like bounce back and forth to the details panel or try to find the rotation gizmo or any of that. You're just kind of like, how do I find the best lighting response for this scene? Including going from complete sunrise, blackness to sunrise. You get that nice, really bright red line from the Rayleigh scattering. So jumping in real quick to, we have kind of an invisible material applied to this sky dome right now, but we could apply that 2D texture-based sky real quick, which once it's in motion, it might be a little bit more clear that it's a texture-based offset effect, but it's still pretty, hopefully conveys the point of why you would want to tie in just a simple fake sky dome to your atmosphere, so that at least you don't have jarring, floating sky cloud polygons, on top of the fog or something like that. You want something reasonable. And then for the other clouds, we have that volumetric example here as well. These are a little bit more heavy on the performance side, but you can see these are actually fully volumetric now. So the way that the shadow moves is a little bit more accurate, and we can actually kind of fly around. And although the fog sorting hasn't been implemented yet to work inside of those, and these are just a prototype example, basically showing what's possible. But you can kind of change the volume dynamically and change the altitude of the clouds, change the tiling of the clouds. You might need to add a 0 in there. There's kind of a detail layer which is breaking up, which you want to keep these detail layers kind of correlated to each other between sane values. But it's pretty, you can kind of hone in on some different sky settings pretty quickly. You could have, what if I wanted to have a completely clouded sky? You're still benefiting from the physically based sky because now you have that nice red sunrise and everything like that. And this was just kind of a quick prototype again, so imagine what you can do once you really sit down and calibrate everything and make it all physically based and correct. So jumping back over here. So in summary, improved streaming management and level editing tools are on the horizon, and that includes things like grid systems and file per actor. New ways to edit landscapes and worlds, we're exploring those now, and that's the layer system, blueprint brushes, procedural foliage improvements, and all those types of things. And a lot of the new rendering tech that benefits all of this is already here to play with now, and that includes things like the sky, virtual texturing, and a lot of the other rendering features that Nick mentioned in the keynote, like the screen space GI even really helps rocks pop, although we don't have examples of that in this talk, unfortunately. So I want to give a big thanks to our open world teams, our tools teams, rendering, and tech art teams back at Epic who helped contribute to so many of these features. And I also want to thank all you guys for attending and your interest in the Unreal Engine. So thank you guys, that's it for me.